So far in Chapter 13, we've talked about the difference between an experiment and an observational study. We've talked about the components of an experiment like factors and levels and response variables. And then we've also talked about what makes a good experiment. And we're going to move on now to the different types of experimental design. The first type of experimental design that we have is a completely randomized design. This is very similar to a simple random sample from Chapter 12 in sampling. And these subjects are randomly assigned to different treatments using a random number generator or the lottery method or hat method. Block design is another type of experimental design. It's very similar to a stratified sampling method that we talked about in Chapter 12. This is where you divide subjects into two groups or blocks based on like characteristics. Then you randomly assign each group to different treatments using either a random number generator or the lottery method. This is really important when you think that treatments may affect different types of people differently. Let's say you're testing a new drug that you think is going to have a different effect on older people than it does younger people. So you may want to block by age group so that you can test how that drug affects the different age groups. So really, why block? Why is it important, like I said in the other slide, that medication is going to affect someone that's older or younger differently? Well, blocking allows us to reduce the amount of variation to improve the accuracy of our conclusions by creating more homogeneous groups. So like I said in the previous slide, that we would have groups that contained people that were older and then groups that had people that were younger, because we think that the drug may affect those groups differently. So we may have, great improvement in the older group and then not very much improvement in the younger group, and that's a whole lot of variation between the two groups. But within my older group and my younger group, there will be less variation, and so overall it improves the accuracy of my experiment. Matched pairs is a type of experimental design where each subject in the experiment is going to test both treatments. So they will receive two treatments and are not going to be either put in this treatment or this treatment. They will go through both treatments. Now, to preserve a randomization, the order in which they receive those treatments will be randomized. So a group will be randomly selected to do treatment A first, but then after treatment A, they will also receive treatment B, and then the other group would have been randomly assigned to do treatment B first, and then will eventually also do treatment A. Blinding can be really important in an experiment because it can help control bias. There are two types of blinding. There is single blinding, and that's when the participant does not know whether they are part of the treatment or control group, so they're just unsure of what group that they are in. And then there's double blind. That's where both the participant and the experimenter or researcher are kept in the dark as to who is in the treatment and who is in the control group. The placebo effect is a beneficial effect produced by a placebo drug or treatment which cannot be attributed to the properties of the placebo itself. Therefore, it must be due to the patient's belief in that treatment. An example of this would be, let's say that I'm testing a drug for migraines, and I'm giving one group that new medication, and then I'm giving one group a placebo pill. And then the people that are receiving the placebo pill are self-reporting that they are having less migraines. Obviously, that was just a placebo. There should be no reason that they are having less headaches other than the fact that they actually believe in the treatment.